There's just a couple more ideas that I'd like to talk about in this last video before we wrap this section up. The first thing I want to do in this example is reinforce the idea that the definite integral tells us the net area under a curve rather than total area. Remember, net area means that any area above the x-axis, that's going to be counted as positive. Any area that's below the x-axis, that will be counted as negative. So first up, I want to evaluate the definite integral from a to b of f of x dx. So here I want to start at a, so right here, and go over to b and find the area that's bounded between my function and the x-axis. So here I'm telling you that that area is 10. So I know that my integral will either take on a value of 10 or negative 10. I just need to think about, well, should that area be positive or should that area be negative? In this case here, this red shaded region, this all falls above the x-axis. So because this red shaded region is above the x-axis between a and b, this definite integral will be positive 10 because, again, this red shaded region all falls above the x-axis. Next up, I want to evaluate the definite integral from b to c of f of x dx. So starting right here at b, integrating to c, I want to find the net area bounded by my function and the x-axis. So we're looking at this blue shaded region right there, which has an area of 6. And I need to keep in mind we're talking about definite integrals. We're talking about net area here. So the net area of my function between b and c in this case would be a negative 6. That would be a negative 6 because this blue shaded region, this all falls below the x-axis. So that entire blue shaded region falls below the x-axis, so we're counting this area of 6 as a negative 6 when we talk about the net area here. Next up, I want to look at the definite integral of my function from b to d. So here's b. I want to integrate from b to d over here. So I'm finding the net area between b and d. Again, we're going to count this blue area, that area of 6, that's below the x-axis, so that is going to be a negative 6. But now I also have this green area, this positive 2, that lies above the x-axis, and I sort of just gave it away here that this green area is entirely above the x-axis, which means that this green area will be a positive 2 rather than a negative 2. So I just want to take negative 6 plus 2 here in this case just gives me negative 4. Finally, we'll integrate this function from a, so starting right here, all the way over to d. So this means we're just going to add together all of these areas, counting any area above the x-axis is negative, any area below the x-axis, area above the x-axis is positive, area below the x-axis is negative. So here we'll take the area between a and b, that's 10, and since it's above the x-axis, that should be positive 10. Add together the area between b and c, that's 6, but because that area falls below the x-axis, we're going to make it a negative 6, plus the area between c and d, there, that green area, we have 2, and since it's above the x-axis, that is a positive 2. So I have 10 plus negative 6, that would be 4, plus 2 here is a positive 6. So you'll see some examples like this in the homework, and there's a good chance I will ask a question like this on your exam. I'll give you this picture and ask you to evaluate a definite integral just using this picture. and you have to use the fact that the definite integral tells us the net area. Again, we're counting any area above the x-axis as positive, any area below the x-axis that is negative. The last big idea for this section is average value. So if I want to evaluate the average value of a function over an interval, so say from a to b, it's simply the definite integral of our function from a to b, so just the definite integral from a to b, and then we'll divide that by the length of our interval, 1 over b minus a. So we'll in this case, you can think about it as dividing by b over a, so we could write this as the definite integral from a to b of f of x dx all divided by b minus a, but I think that's too much. I always prefer to multiply here, so we'll just multiply by the reciprocal. We'll multiply by 1 over b minus a. So here I want to find the average value of f of x equals 6x squared minus 2x over the interval negative 2 to 3. So here this is hopefully should feel like a relatively straightforward application of this formula here. So 1 over b minus a, this will be 1 over 3 minus negative 2, times the definite integral from negative 2 to 3 of our function f of x, that is 6x squared minus 2x, minus 2x dx. So I'm just trying to evaluate this definite integral, and then at the end of this, I'll multiply by 1/5. So here, 1 over 3 minus negative 2, that is 1/5. Here I need to find my antiderivative, so let's see, I will have, what will I have there? 3, nope. Let's see, 6x cubed, 2x to the third, there we go, minus x squared, evaluated at 3 and negative 2. It's up to you whether you want to multiply this 1/5. You could actually distribute it here if you really wanted to. You could multiply both terms, the f of 3 and the f of negative 2 by 1/5, or you could just multiply the result by 1/5. It's up to you. I'm going to leave this out. I'm going to say here's 1/5, and I'm going to start by evaluating this at 3. So this will be 2 times 3 to the third minus 3 squared minus 2 times negative 2 to the third power minus negative 2 squared. And I'm just trying to evaluate this result. So 1/5 times, let's see, 3 to the third would be 27 times 2. I should have 54 minus 3 squared would be 9. Minus over here, negative 2 to the third power would be a negative 8 times 2 would be a negative 16 minus negative 2 squared, that's going to be minus a positive 4. So let's see, I have 1/5 times 54 minus 9, that should give me 45, minus over here is negative 16 minus 4, that would be minus negative 20. So here I have 1/5, oops, and I'm kind of running out of room here. I end up with 1/5 times 65, which should be 13. So for the most part, if you know this formula, it's a relatively straightforward process. You're just going to do the definite integral from a to b and then just multiply the result by 1/5. Notice I really didn't do a whole lot with this 1/5. I just kind of brought it along for the ride until the very last step when I went ahead and multiplied the result of my definite integral by 1/5. Last thing, I just want to draw a distinction between average cost and average value. So here we have an example. It says the total cost of producing X dictionaries is given by C of X equals 20,000 plus 10X. Part A says find the average cost if 1,000 dictionaries are produced, and here we're given the hint, use C bar of X. This is something that we haven't seen in a while. It's probably good since we have a final exam coming up. If I want to find the average cost is given by C bar of x, which is C of x divided by x. So you could, if you wanted to, take 20,000 plus 10x over x. We could simplify that and say 20,000 over x plus 10 if you really wanted to, or you could just leave it like this. It's up to you. But I want to evaluate this if 1,000 dictionaries are produced, so I want C bar of 1,000. So here I'll have 20,000 plus 10 times 1,000 divided by 1,000. Oh, and here let me grab my graphing calculator. 20,000 plus 10 times 1,000 be 30,000 divided by 1,000. Here I have an average cost of $30 per dictionary. So there is my average cost, and I want to contrast that with the average value of the cost function over the interval 0 to 1,000. So here we're talking about the average value. We want to use 1 over b minus a times the definite integral from a to b of our cost function c of x dx. Excuse me. So I'm just using the average value function that we gave earlier. So let's see. We want 1 over 1,000 minus 0 times the definite integral from 0 to 1,000. C of x. What was C of x here? We said that was 20,000 plus 10x dx. So this is 1 over 1,000. Let's see, our antiderivative, that will be 20,000 x plus 5x squared, evaluated at 1,000 and at 0. So I have 1 over 1,000 times, here I'll have 20,000 times 1,000 plus 5 times 1,000 squared minus 20,000 times 0 plus 5 times 0 squared. So first of all, 20,000 times 0, this is going to be 0. 5 times 0 squared, that's going to be 0. We don't need to worry about that part over there. So I have 1 over 1,000 times, let's see, 20,000 times 1,000 plus 5 times 1,000 squared. Take that result, divided by 1,000. I have what looks like, here, let's just jump to the results. I should end up with $205,000. So this is the average value of the cost function over 0 to 1,000. Notice that this number is really, really different than our average cost. So make sure that you're paying attention in this section. We want to make sure that we don't mix up average cost or average revenue or average profit with average value. They both have that word average in it, but the process that we use to find them is very, very different.